Hi everyone, this lesson is about integration, or antiderivatives as they're called. So let's begin with something like this. We're given a problem dy dx equals 2x cubed, and we're asked to find the function of y, so y as a formula using x. So the way we approach this is to first of all move the dx infinitesimal to the right hand side. So the x variable and the infinitesimal dx are together and the dy infinitesimal is here. Then we take an antiderivative or an integral of both sides. We do the same thing to both sides. Now the integral of dy is y. This, the constant 2 just stays there. The power on the pronumeral x increases from 3 to 4, and then we divide by the new power. And we add a constant of integration. We would simplify to read y equals x to the 4th divided by 2 plus c. And that's our antiderivative, or our integral. We could easily check our work by taking the derivative of this formula. If we take the derivative, of course, we end up getting 2x cubed straight back again. Derivative of the constant is 0, and that's why we have to include that as part of a general solution. So that's a pretty straightforward one. Let's try one that looks a little bit like this. So the difference this time is that we've got more terms involved. We have a quadratic formula here given as a derivative. So how do we deal with that? Well, this is what we do. We start off much the same. We have 3x squared minus x plus 4, and then I'll need brackets here when I put my dx. I'll take an integral of both sides. The integral of dy is y. Now this is really saying the integral of all of these things, and we can do them in 3 separate steps. It's the integral of the first term with respect to x minus the integral of x with respect to x plus the integral of 4 with respect to x. So when there's a number of terms added or subtracted, we just take the integral of each piece one after the other and add or subtract as the case may be. So it's like 3 little problems all in one. Again, the coefficient 3 will remain as a 3. The power on x will increase from 2 to 3, and I divide by the new power. Subtract. Now, I'm just going to put in red here a power of 1 on that x. You don't need to write that. I'm putting it in there to explain my thinking. You can just use your imagination in future to think of this as x to the power 1. So that power of 1 increases to become a 2, and I divide by the new power. Likewise, on this next bit, I'm going to imagine here this is 4 multiplied by x to the power of 0. Again, you don't have to write the part that's in red. So it's addition. The coefficient 4 will be there. The power of 0 will increase to a power of 1, and I divide by 1. And then I add a constant of integration. Of course, we would neaten this up a little bit. That simplifies to x cubed minus 1/2 x squared plus 4x plus c. And that's our antiderivative, or our integral, of the quadratic formula that we were given to start with. So again, we could check our answer by taking derivative of this to see that we actually get the quadratic formula we started with. Alright, that's enough now for a quick introduction. 2 simple examples of antiderivatives, and thanks for watching.